Okay, in this video we're going to go over 6.3 and 6.4 for the Ryken Geometry Final. So here we're proving triangles similar by angle, angle, side, 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 and side, angle, side. So once again, if shapes are similar, they have exactly equal or exactly congruent angles, and they have sides that are in proportion. Okay, that's the definition of similarity. So there are three ways that you can prove triangles similar. One is if you can find two angles the same. A second is if you can find all sides in proportion. And a third, if you can find two sides in proportion with the sandwich angle in between the two proportional sides being congruent. Okay, so look at 28 with this in mind. So I have 3 and 4. So I wonder, the smallest of those is 3. So is 3 and the smallest of the other pair is 12. Does this have the same proportionality as the second size, the 4, is to 16? So what do you think? Well, it looks to me like, let me just change color. I believe 3 goes into itself 1 time, 3 goes into 12 4 times, 4 goes into itself 1 time, 4 goes into 4 4 times. So therefore, yes, these are indeed proportional. What about the angle in between? This is the sandwich angle. Are those sandwich angles equal? And the answer is yes. So by side, so what are the sides? Let me just change color. By side, angle, side, I have side, angle, side. These are indeed proportional. And if they're proportional, the sides are proportional and the angles are equal, you can prove similarity by side, angle, side. Okay, let's look at the next one. You've got to write in some information. So, what do I know? First off, I see that I have vertical angles. I also see that I have no measurements of any side whatsoever. So my only potential of proving similarity is by angle, angle. But I have no angle marked yet. So can I find some that are equal? Because remember, you have to find two angles that are exactly equal. Well, I found one here. This top triangle and this bottom triangle have vertical angles that are equal. So that's one of them. Okay, so now look what else I have hiding in here. If you think of VW as a transversal and you have these parallel lines right here, what's happening is these are alternate interior angles, and the alternate interior angles are equal. So I have found two angles equal, the verticals and the alternate interior. So by angle, angle, I can prove that the small triangle on top and the bigger triangle on the bottom are indeed similar. So I would expect that the other angles are equal, and also that the sides are in proportion. Okay, so I have so far proved by side, angle, side, and by angle, angle. Okay, let's look at this last one for number 30, the last one on this page that we can see. Okay, in the first triangle, the smaller of the two, I see I have angles 45 and 85. Okay, so I have 85 and 85 here and here, they match. But 40 does not match 50. 45, does not match 50. So figure out the missing angle. So in the smaller of the two triangles, I'm going to say 180 minus 35 minus 45. And I find that the missing angle, so let's see. Am I getting that right? Here, let me get back to you in 2 seconds. Okay, so I misspoke. So the two angles are 45 and 85. So in this triangle, so far I have 45 plus 85. Okay, so 180 minus that sum. So 180 minus 85 minus 45 gives me a remaining angle of 50. So right over here, in the angle I don't have, that angle is 50 degrees. Okay, look, this angle is 50 degrees. Let's find its missing angle. So 180 minus 85 minus 50 degrees gives me a missing angle in the bigger of the two triangles of 45 degrees. So now, not only do I have two angles equal, I actually have three angles equal. So by angle, I can prove that I have similarity. Okay, now, they want us to do a similarity statement. So I'm going to go back now, erase what I have, and we'll talk about the similarity statements. Okay, so here's part 2 of this. So looking at the first pair of triangles in 28, I said by side, angle, side, I have similarity. So what I would tell you to do is put the letter of the angle that you know first. So in the small triangle, I have an L. In the big triangle, I have an X. Then go from the L in the small triangle and go down the small side. That will bring me to the J. In the second triangle, start at the X, go down the small side. That will bring me to the Y. Then just fill in the next letter. The next letter in the small triangle, L, J, K. That's similar to X, Y, Z. Okay, I started out with the angle that I had in common in the side angle side. So that is your similarity statement. So triangle LJK is similar to triangle XYZ. Okay, that's very important. Okay, next one. What I had done angle similarity. And what angles did I find similar? Well, I found the vertical angle similar. And then by doing parallel lines in a transversal, I believe I had this one and this one similar. So let's start writing our similarity statement. Start with the common angle. Y is common to both. In the top triangle, go to the W next, because you know that W equals the V. So in the bottom triangle, go to the V next. Then in the top triangle, the remaining letter is the X. And in the bottom triangle, the remaining letter is the Z. And that is your similarity statement. So we have YWX is similar to YVZ. Okay? And let's see. Let's do the next one. So in the next triangles, what I know is that I found missing angle here to be 50, and I found missing angle here to be 45. Okay, so this is the similarity. Oh, here was angle, and it's going to be angle here as well. Let's write a similarity statement. Why don't we start with the 85 degree first? So that's L in the small triangle, and it is X in the big triangle. Then let's go to the 45. That is J. The 45 in the big triangle is Y. And then let's go to the remaining angle, which was 50. So that's X. The remaining angle of 50 is Z here. So your similarity statement is that LJX is similar to XYZ. Okay, so we're going to do question 31 on the next page. So for question 31, I have no angles whatsoever. So in terms of figuring out whether I have similarity between the two triangles, what I'm going to do is set up proportions and see whether they will work. So in the small triangle, the smallest side is 3. In the bigger triangle, the smaller side is 6. In the small triangle, the medium side is 4. In the small triangle, the medium side is 8. In the small triangle, the biggest size is 5, and in the big triangle, the biggest size is 10. So what I'm seeing is that each of these can reduce to 1/2. 1/2 is my scale factor, and I do indeed have similarity. Okay, so now let's talk about your angle sizes. Okay, so where is the smallest angle? The smallest angle, we have to label this first. So let's use some letters. So let's make this ABC, and we'll make this DEF. Okay, so I'll change that on my copy. So I have ABCDEF. Okay, so similarity statement comes next. What is the smallest angle? Well, the smallest angle is across from the smallest side. So C is the smallest angle, and F is the smallest angle in the bigger triangle. Those are congruent. So to do a similarity statement, start with C for the small triangle, start with F for the bigger triangle. Okay, look at the 4 side. That side is opposite the medium angle. Okay, which is the median side here? Well, it's the 8. So that means E is across from the medium side. So the median angle is B for the first triangle and E for the second triangle. Okay, complete the triangle. CBA has to be the next. FED has to be the next for the bigger triangle. And notice that A and D are both across from the right angle, or from the corner angle. So that will be the biggest angle. So yes, that's my similarity statement. So you can say that you have similarity statement CBA is similar to FED. All right? So those are our similarity statements. They don't always have to be identical, but you have to have angle C aligned with F, angle B aligned with E, and angle A aligned with D. So just for an exercise, can't I also write this triangle as ABC? If I write it as ABC, then A went with D. So this is similar. A went with D. What did B go with? E. And what did C go with? F. So you can write it ABC is similar to DEF. So there are many ways to write it as long as you are consistent. Okay, so that ends the video for 6.3 and 6.4.